All right. This is going to be a good one. Good one, good one. I'm so excited, guys. So I have got the new setup completely installed, which means that I have 1, 2, 3, 4, 5 cameras. I have 5 different cameras. And this is going to be a game changer. And I'm going to show you guys today exactly why this is going to make such a difference. So, hey dog, what's up? So guys, today I'm going to experiment with this camera setup, and I have everything in its position, so I don't even have to change anything, which is kind of cool. So like I can switch over here and I can start talking to you guys here, or I can switch to the overhead and you know, we can do some stuff overhead. But I have a couple new things that we're going to try. Like I can do a split desk like this. How crazy is that? So guys, I think maybe I'm going to experiment with this one, see if I like the setup or not. But nonetheless, guys, I have microphones and stuff set up. I have everything adjusted, I think. So I even have audio playing back on my track while I'm sitting here and doing this. So I've been striving to get to this level for years, and finally I've got my garage set up. Guys, this is so fantastic. But anyway, happy Friday, everybody. So believe it or not, I do have some homework, and I bring some of my stuff home. And because of that, I have the ability to do videos for you guys. You know, how cool is that? And today's victim is a Secor. And this guy has some interesting problems. So yes, first off, it's acting like it's got a low battery, even though I can plug it in and I can charge it. But this poor guy feels like the motor's froze up. And I take it that this is probably a brushed DC motor. We're going to find out. But also, it's got a 3.3 amp 12 volt battery inside it. So I guess what we should do is probably go through and open this guy up. So here, let me show you some of the other cool new stuff that I've been working on. So I can pull this guy down right here. Here, let me turn it on first. So one of the cool things that I can do, I'll use my phone right here as an example, is I can switch this guy over, bam, and I can do microscopes, which I probably should have turned it on before I did that. But I have a microscope that I can do screen captures with, which is going to be a huge plus because I'm going to do some soldering videos and probably some board level repairs. And this is what I've been striving to get all along. You can see my microscope, which is mounted on a spring arm, so I can bring it all the way out. I have a screen up here, which screen is not really doing anything because when you know it, one of these Chinese microscopes, it only has one video output. So it does HDMI or it does something else. But the cool thing is the focal range of this microscope is incredibly high. So I can get you guys crystal clear video from up here. So way up here. So that's out of my field of view. In fact, I can still talk to this right here. I can still talk to you guys even though the microscope is in view. And you know, I can still work on things as I need to. This is what I'm talking about. This is what I've been trying to get to for a long time. Do I have a variable power supply? Yes, I do. It's right over here. And that's one of the things that we're gonna check out, because I use the regulated DC power supplies to test motors. And that's because you can hook them up, you can run them at their rated voltage and see how many amps they pull. It's incredibly convenient. I wish more people used DC power supplies for troubleshooting. But anyway, guys, let me go ahead and turn this guy off and set him off to the side because I don't think I'm going to need him for this video. But everything has a place. It just kind of sits right over here above my monitor, and I swing it over when I want to do something. Guys, this is going to be so cool. I am So excited, and I wish I could show you guys. I'll probably walk you guys through the whole setup sometime, but anyway, I think my camera is still tracking me too. Yeah, it is. Look at this. So I have a gimbal camera that is even following me around. So if I'm ever walking around, it's gonna track me. Pretty sweet, huh? It's gonna make it way more convenient because I don't know about you guys, but sometimes when I'm out walking around and I want to talk about certain things and whatnot. Actually, now that I have this green screen, that's probably what I'll do. I'll probably I'm gonna change this green screen to my Windows backdrop. So if I'm explaining theory or something, I can, explain it here on the green. I've had this guy for a long time, and I've always wanted to do something here so that I could talk to you guys, and I just never had the ability. But now I do. Now I do, guys. All right. All right. So here's what we're gonna do. We are going to minimize this guy, and we're gonna open this guy up because I have no clue. I have no clue what's really going on with it. None at all. I can hear the motor try a little bit. Could be that the batteries are really that dead because 12 volt, especially 12 volt lead acid batteries. If you guys have ever had a car that you try and jump start, and even though you have a good 12 volt battery feeding it, it could have cells that are dead. And when those cells are really dead, they actually sag and they bring down the battery that you're jump starting it with, which could be exactly what's happening over here on this guy. Even though it's plugged into the wall, if the plates inside the 12 volt battery are shorted together, then it will pull it down. So you're exactly right. It will pull down the PSU, and we will see it. And maybe, because I have the room cam right there, I can swing that bad boy around when I show people troubleshooting. See, there's so many things I could do over here that I haven't even really explored yet. But that's why we're gonna. And one of the reasons I'm doing the live streams, I'm gonna be doing a lot of them, is for one, it's convenience. I don't have to edit. Do you know how much time it takes to edit? But I do have an editor now. And next week I'm gonna start working with him. And we're gonna see how that goes because that could be rather expensive, but it just depends on whether or not I like doing this format or pre-recorded format better. Scripted, pre-recorded videos get a little bit more action in the end, but they take so long. So anyway, guys, do this. All right. Wallach zoom scope. I've got several extra microscopes. Maybe that's what I'll do. I have a few microscopes, and I might give them away. I've got a few of them, and some of them have been donated to me. Some of them are just extra soldering microscopes and stuff. And I even have an extra digital microscope. This one here was one that was donated to the channel, and I love it. I love its focal distance specifically. But Catherine, there you are again. Hello, ma'am. All right, guys. So what we're gonna do is we are going to explore one of these bad boys right here. Let's switch it. Bam. Here we go. Or I can do this one so you guys can see what I'm doing. Oh, kind of creepy. Not really. All right. Here we go. So, guys, this is a C-Core. It's lived out its days. All right. But, I don't believe that anything is truly dead. So, guys like this, it's probably perfectly serviceable. We're going to find out together, though. Let's do it. So I clearly see that I'm going to need a number 1 Phillips and a number 2. Number 2's for the main case. And look at this, man. My setup is so clean that now I have a space for everything, even my parts. Now what I wish I really had space for is a rack. A rack with shelves. So when I take things apart, I like to keep all the parts together. It just, space is such a thing, man. Okay, so let's see. There's 2 fasteners in the handle. See, I can actually swing this guy way out too. Ready? Let's do it. Look at that. So I can show you guys way up high, over top. How about something like that right there? Bam. There you go. Didn't tighten that guy enough. It's cool to have this to move my cameras around really quickly because you know, I might be working on different formats, different sizes of devices. I can't tell you how nice this is going to be, y'all. Okay, so to open this case, I can see the seam goes down the middle, and your waste container here, it's going to be an issue. I can tell already. So that means we got to pull out these number 1 Phillips. And let's see, I've got one hidden one underneath. I hope my audio is coming through nice and clear, guys. Because today we are going to learn something about suction units. Again, I have never pulled one of these apart. This was brought into me because they think it's garbage. They think it's garbage because the motor is seized up, and that actually might be garbage in many situations, but not here. Not here, folks. Okay, let's see. All right. Oh, my goodness. All right, so we got a variety of different length of fasteners. Lovely. There we go. Okay, so let's see. What do we have here? I've got... Okay, now I've got more fasteners. Gosh darn it. It looks like this was an afterthought by these little tiny fasteners that they kind of just put in there. So it's probably like a dovetail, and I'm assuming that these are just holding it in. I guess we're going to find out, huh? Yep, there it is. There it is. All right. So, yep. It's not really a dovetail, it's a T-track. You can see the T right there. Close enough. And that is keeping the case together on this side. So fasteners here, they're squeezing in on that T-track. Let's see, I've got all the screws out, and it's probably ready to crack open. Now this guy here, this is interesting because it's got a threaded, what is that, 1/4 inch pipe fitting. And this little pipe fitting right here, looks like it's for a muffler. All right. And you can see that at one time, you know, they put, I guess that's kind of a muffler. They put a filter / muffler right here. It's all right. No tape or anything on it. Good. We're good. Okay. Wow. Definitely heavy. Okay. So I'm going to go ahead and disconnect the silicone tubing right from the pump. It's got a cool looking pump. That's right. Okay, let's disconnect that guy. Wait. All right, so there's one. I have a Molex connector on, what is that, a control board? Yep. And let's see. Okay, right here's my AC in and ground. All right. Let's go ahead and get that ground off of there. There we go. Oh, geez. And because it's bent so, the fastener's actually captive. Whatever. All right, cool. So right here on the back of the unit, you can see I have a 12 volt, 2.8 amp hour SLA battery. And this guy is plugged into what I thought was a control board. I guess it is. Okay, so this is probably your timer, your intermittent. Does this have intermittent? Does not have intermittent. It's got a manual vacuum regulator, which is basically just a needle valve. So I have a switch mode DC power supply right here. Very simple, easy to diagnose. It has no standby power or anything, so it's just always on. These are the easy to troubleshoot. You can just check your voltage in, check your voltage out. That goes into this Molex connector, which goes into your battery management. So this board back here is technically a control board, but it also is a battery management and charger. You can see your voltage regulators right here and right here. Tell you what, I really want to hook up that microscope. Oh gosh, but if I do it, I think it will shut off my stream. Hold on, guys. I really want to get, oh, come on. Come on, microscope. Work, darn you. I don't want to cancel my live stream. Come on, work, work, work. Let's do room cam. Microscope. Come on, microscope. No. So there's some glitches to some of the software I'm using. Like everything has to be on there when I boot it up. This guy here, I could get you such a crisp and clean field of view. Gosh darn it, I'll have to remember that. Next time I might want to even think about using my microscope. It's got to be booted up by the time I boot up OBS. It is what it is. All right, let's get back to it. Okay, guys. Anyway, I can show you this way. It's not as good, but, you know, it is what it is. So anyway, you can see I have a couple voltage regulators here and here. Actually, one of those might be a diode for the battery, because you don't want reverse flow into your battery for whatever reason, including if, no, it can't be hooked up backwards. Sometimes they put a diode in there to prevent reverse biasing into the battery, but nope, those are probably both voltage regulators. So one of them is probably to limit or to manage voltage from the power supply to power the control board, and the other one is your battery maintainer circuit, which monitors your charge and charges accordingly. So the Molex to the front looks like it has LED indicators for your battery status and your membrane button for your power on. And that is all it does. Oh yeah, and a little AC power indicator. So tell you what, let's go ahead and let's check out this bad boy and let's see what our voltage is on the battery. Now I have let this guy, let's see, okay, that's interesting. I have let this guy charge for a while, so it's not necessarily a matter of charging, which is why the motor's froze up. I think it's really just, you know, the motor has either been sitting for a while or it is a brushed DC motor, so it could be just that, you know, maybe it's had too much wear and tear. Or they might have sucked fluids into it. What are the odds of that, right? Actually sucked bodily fluids into the emergency suction unit, thus gumming up my pump. In fact, son of a gun. Gosh darn it. All right, guys. Well, tell you what. I don't know if the camera's going to pick it up too well, but if you notice some dots in the case, let's see, especially down here. See the dots from spray? You can see little brown dots on the plastic on the inside, down there by the IEC power port. See those dots? That is shmoo from something, which is probably why I'm going to get gloves. All right. I was thinking because this came from a little clinic that it's probably just been sitting for a while, but what really happened is because it's from a restart the stream. Oh, next time. Yep. So I'm going to check the battery voltage right now. what happened is this unit, because it's in clinic, the staff were probably not very familiar with using it, and either they filled up the tub that all the schmoo goes into, or they used it without a tub and they used it as a direct suction, which could happen, which is also very disgusting because that means everything went into the pump. And let's not rule that out, all right? That could be what happened. Let's check that battery. All right, so let's see. We got 3 leads on this battery. So we have 3 leads because, why do we have 3 leads? Now I'm curious. Often we have 3 leads because what they do is they take 2 batteries and they put them in series or parallel, and one of the leads is usually in between the 2 cells. So you have cell voltage and you have a split cell voltage. That way there, cell 1's at 3.8 volts, the other cell's 3.8, together they're 7.2 volts. That's why they usually have 3 leads, but I don't know, guys. Okay, let's see. Okay, and you can see right there, I have 12.69 volts on those 2 pins. Let's try the other 2. 12.7 volts on the other 2. Now I'm curious. It looks almost like the negative terminal is together. I don't know. Maybe we'll open it up and find out. Don't really know. Medical batteries do some weird things, and it's usually for some sort of protection. Okay. Let's see. Use gloves. Yes, please. I got some problem with the end user. They let oh no, overflow, and it went to the pumps. That's what I'm worried about this guy. Sometimes screws that hold the reed valves on reciprocating pumps vibrate loose and slam into the piston. I have also seen something like that. We're gonna find out. We are gonna find out. But anyway, on this guy here, everything here checks out perfectly fine. So the charge controller is obviously doing its job. The battery is doing its job. It's struggling because of that pump. So, guys, that is the back case. There's a lot going on there. I like that. All that's easy to troubleshoot. Power supply, everything easy to troubleshoot, okay? So let's see. Here, let me get this keyboard out of here, because something is going to either hit that keyboard and cancel this stream or something. That's my luck. Okay, so in here we have our gauge set, and down here this is our basically our needle valve, which is a bleed out. In other words, it vents some of the vacuum to atmosphere. So that's how you can decrease the amount of vacuum. Look at that. That looks so cool on that camera. My gloves. My hands aren't that dirty, I swear. It's the lighting. But anyway, this guy here, it's this guy. And what it does is when it's all the way down, it is closing the vent to atmosphere. So you're getting total vacuum from the pump. When you slightly open it, the needle valve opens up and it creates a little crevice. And as it creates a bigger and bigger crevice, it allows more atmospheric air to get in, which decreases the amount of vacuum. That's how it works. It's interesting that they stuck the IEC on the front of this case. Really weird, because that means if it's plugged in, it would often be facing away from you. Odd, definitely odd. Okay, let's pull that dingle hopper off right there. Guys, it's hanging right up here by my face. Kind of annoying me. Anyway, all right, let's see. The pump is held in by, 4 fasteners on a tray. Okay, so there's 3 fasteners, and it's on a tray. So I've got a grounding strap right here, which grounds the front panel. So I can take that guy off first. Yes, I am going to take it off with just needle nose pliers. There we go. So they put it on a crazy long stud. Look how long that thing is. That's wild. Design engineers, what are they doing? Okay, so there's your grounding strap for the front panel. It's interesting. Come on. And what's really weird is they put a, hold on, let me show you better. Here you go. They stuck one of these style fasteners on there. You see it? So that's a metal nut right there with the little crown that helps it hold down things. And then underneath that, they stuck a lock washer. That's really unusual. So it was like that stacked. I don't know. That's not normal. Anyway, okay. Let's get down to that pump. Grounding strap can now come off. Go here. Get my large flat blade to help me clean out some of these cables. So this whole metal plate down in the bottom will slide out if I take out these two screws back here. Those are number 2 Phillips. And then this one over here. So this bottom tray is screwed into the front face. Definitely interesting. All right. Come on. There we go. There's one. And there's 2. Cool. See if I can keep all my tools nice and organized. So that tray is technically ready to come out. I've got one ground strap right there, which eventually is going to be a problem, so I might as well remove it right now. Come on. Wow, that guy's really screwed in there. It's screwed into the composite of the pump. And that guy, you can tell it's self-tapping. It's coming out pretty tough. There we go. Okay, so let's capture it. And it has a metal lock ring. Cool. Now I'm going to go ahead. I always put my fasteners back in the same hole, just loosely, like that. That way there, everything stays together. Okay, so I have a ground terminal right here on the IEC. That's going to have to come off. And if they would have just put like push-on spade connectors, they soldered it. But if they would have put just a push-on spade connector, you'd just be able to pull it out. Super easy. But that's not how we do things, right? We're going to make it more complex than necessary. And more screw down terminals. All right. I'm just going to drop these guys over here. Come on. All right, so there's one of my ground wires. And I got 2 more. Gosh darn it. Oh, well, I guess I could have just done this without disconnecting that one ground. Okay, there's that one. At least it's grounded, right? There we go. Okay. All right. There's my IEC. It's disconnected, and we are ready to pull it. So I got my silicone tubing, pulled it off the pump. This guy should just pop out. Should, right? Come on. It's being a little shy. There it goes. There it goes. Need a little coercion. All right, there it is. And you can tell on the bottom that there is some sort of history of shmoo with this pump. All right. It is what it is, right? Now you have a much better view of the splatter effect. Whatever happened there, don't ask, don't tell. Let's just leave this guy someplace over here. All right. Now, this guy. So the first thing I should do is remove it from this disgusting platter. Oh, these ones are coming out easy. All right. I dig that. So we got 3 taper head screws. So if you guys didn't know, the shape of your fasteners tells you a lot about where they belong, okay? So if you see that this is a taper head, you see how it's got a flat face and it's got a tapered neck, those ones will always go into a countersunk hole. Sometimes it's aesthetic, but usually it's for function. Like they choose to make it flat in this case so that would fit smoothly into the base. Here we go. What is the current draw of the pump on the bench supply? So you guys want me to, before I take it apart, you want me to hook it up and do a current test. That's pretty fair. I have the habit of pulling things apart without doing a complete preliminary, but I'm pretty sure that this bad boy is gonna pull some volts. So I got 15.1 volts. This pump here under load should pull maybe what, 3 or 4 amps, maybe. My DC, regulated DC power supply, it tops out at 3 amps. There's no way it's gonna pull just free like this. It should pull like 0.1, 0.2 of an amp because it's not under load. You'd have to put this under load by like obstructing either the input or the output, and that would put the pump under load as it pushes and compresses and sucks. So yeah, right now it would be not under load. So let's see, how can I run jumpers from here all the way over to there? Hold on guys, we're gonna figure this out. All right, I got these leads to here, and all right. I just need to get longer leads, right? So my power supplies are over there, so I'm gonna do black to white, yay, and I'm going to do red to yellow. All right, and here I got my mini Molex, and let's see, I'm gonna do black to black, and then this one here, I'm gonna actually, for this type of Molex, you can just clamp to the outside like that. It keeps your terminals apart. And let's see, let's go ahead and set this guy. All right. Come on, turn on. Oh my gosh, guys. Did I not plug in my DC power supply? Ugh. Okay. Let's try this again. Okay, so it says it's 15 volts. We're going to go ahead and set for that. All right, voltage, let's go up, up, up. See what? Let me switch this guy around so that you guys can see what I'm doing, right? That's why we have these cameras and this fancy setup. Okay. All right, and let's lock it. Okay. It's probably going to get the other camera in. There it goes. Come on, come on, come on. Follow me. Come on. Okay, so way over here is my regulated DC power supply. And what I'm going to do is I'm going to turn up the voltage. And it's already not liking it. Let me disconnect one of these. So to set the current, it's already a little warm, guys. It's already a little warm. So set the voltage all the way up. 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so you set your voltage first, and then you clip them together, and you can set your current, right? And it does do a little bit of an arcy spark there. And current, I have currently set at We're going to set it at about 2 amps because it shouldn't pull 2 amps in no way. So let's go ahead and connect it up. My voltage dips down to 2.4 and I'm sitting at 2 amps. So it is pulling 2 amps, which means these wires right here are probably going to get a little warm. It is completely seized. 2 amps, 15 volts. No go. Okay, so let's go ahead and disconnect this guy. So it is completely seized up, y'all. So this is a Kungber regulated DC power supply. So I purposely chose this one because it can handle up to 30 volts at 3 amps. And that matters a lot to me because with medical, we test a lot of oddball things, like sometimes like this motor at 15 volts. Who would have thought, right? Let's go ahead and switch this guy back. Split desk. Bam! There we are. Man, I'm loving this setup. All right, guys. So the motor is kaputs. So is it the pump or is it the motor? And we can separate the motor from the pump right here with these 4. So that's probably the first thing that we should do. So let's go ahead and separate the pump housing. Now if it sucked a bunch of shmoo up, that means the pump is froze up, not the motor. So as soon as I unscrew this motor, we could hook it back up to the regulated DC power supply and it will either spin or not spin. You know, it will have absolutely no load at that moment. All right, it looks like an aquarium pump. You know, it's funny you said that because funny thing about electronics is that pumps are almost all the same, almost all of them. And that's why you can use one to do more than one type of job. It's just fantastic like that. Okay, and let's see, I have these 2 bad boys. That's so weird. So these guys, you can see them threaded down into the deck right down there. How would I get that guy off? Oh, that's not going to work. Right? Nope. It just slides out, huh? Okay. So the motor is connected to something. It doesn't like it. It's probably, well, that's too big of a chamber. So it's clearly got a piston and a diaphragm up here. And then this guy down here is just like an eccentric cam or a crankshaft. So I guess we'll start at the top. Jeez, I thought it would just slide off, but definitely not. Okay, let's take the top housing off, I guess. And of course, these are not coming out easy either. Let's do it. I had to, guys. Screws into composite are the worst because they come out really tough all the way out. Yep, I think you're right. The shaft is almost definitely connected over to the motor. So here we go. It does not have reed valves per se. It's got rubber diaphragm valves. So it's got one going that way and one coming up this way. And if your pump ever doesn't have vacuum, you might want to check in here because what will happen is either these are damaged or there'll be shmoo up and under them so it can't create a seal. And I've had that many times. So this is a really neat composite. It's almost like a ceramic. Really cool. Okay, and I've got one more fastener in the middle. There we go. And then this lid should come off. Here, let's move you over. There we go. Try not to break that seal. And here you go. You can see my other diaphragm right here. Now these ones here, if I can get this motor running, these ones will be cleaned with alcohol. And you know, than soap and water and stuff. It's, if there's schmoo up inside there, that's the best way to do it. I can see some residual right here on the crown, the upper area. Huh, there's not much to it. Okay, and down here you can see the diaphragm's connected to your crankshaft with a single Phillips screw. There it is. And it should be ready to let go now. Try and very carefully coax this diaphragm. Diaphragm's still in good condition though. I don't see any signs of, or is it signs of dry rot? Oh yeah. Yep, for sure. Okay, so this pump is garbage at this point. All right. So I haven't broke this diaphragm yet, but come on, let go. There we go. So what I was looking at is right here where the soft part meets the rigid part. And I was looking to see if there was, nope, there's no breakages. So what I was looking at is that color shift right there. It creates kind of like a line when I stretch it. That line is usually when the diaphragm's starting to tear. Aye. So anyway, it's not tearing yet. So soap and water, I can clean that guy up. That's actually a heavy duty diaphragm too. And right here is the arm. And there's the flywheel down inside. Let's see if I can rotate it. Is it really froze up? Yeah, a little bit. Little bit. All right. And there is normally a fastener. Darn it. There is normally a fastener that you can unscrew to get that arm off. And this whole thing would come off if it wasn't for these two screws down here in the bottom that are holding the feet. Pull the elbow. So here's the problem with it. The motor's seized, and I can feel it. It feels like it's garbage. Here's how we can unseize the motor. We're going to pull the back part of the motor off, which will include the brushes. But we're gonna pull the back side of the motor off, and the rotor should come out with it. Should. Yeah. Okay. There we go. See how bad this guy really is. Okay. All right, there's a preload washer and a smooth washer. I'm gonna put those right here in the bearing housing. This is a good motor. So sometimes they'll use like just bronze bushings in the end cap. You can see it's actually got a properly fitted and preloaded end cap for a sealed bearing. How cool is that? And that bearing's on there good too. Let's see, can I get that off? Come on. Come on, buddy. Is it that bearing that's keeping it from coming off? Let's see, come on, get off of there. Gotta be really careful because I don't want to damage the commutator. And I don't have a bearing puller. Who does nowadays? Ah, yeah. Anyway, it's got a really neat setup here. So this right here is the bushing, or rather, this is your brushes, and you can see the commutator bars, which are the copper right in there. They look really good condition. I need to get this guy off, and it doesn't want to cooperate. This bearing, so there is a way to get the bearing off. That is to heat it up. You heat it up or use a bearing puller And a bearing puller squeezes from the sides and pushes down in the middle, and it'll come right up. Best I can do is something like this, but those commutator bars, if you damage them, the motor's scrap. Yeah, shit, that's... All right, I can't do that without damaging it. I could clean up those commutator bars a little bit. They could use it for sure. A little bit of love. Man, I wish I can get this guy off. If anything, to show you guys a really cool setup. Okay, well, this flywheel's really kind of froze up. Let's see. There it is, there it is. Okay, so I just broke the motor loose by just grabbing onto it and giving it a torque. All right, so that means I should be able to rotate the crank now. Come on. Wow, wow, that is really froze on there too. Well, one of the ways I can get the motor off is to bend these guys, bend them out a little bit, and then it'll pull off. Let's see. Come on. Wow. You can kind of see what I'm dealing with right there. Oh, there it is. So, what a dumb design. It's a really dumb design. Just two little slits and it would have held it in. But they're banking on that. That's going to keep people from goofing with it, I bet. And everything's trapped because I can't get this brush housing off. Oh! I need to get this guy off in order to get the rest of the stuff to slide out. Which means, come on, don't break. Oh, it's going to break. Oh, man. So iffy. I mean, the machine's already broke, right? So it's not like I'm going to break it anymore. It's usually not a good idea to heat up sealed bearings like that. My new ventilator is loud. I use it instead of an air conditioner. Okay, guys. This thing, it just wants to be a pain in my rear end. As does the dog's, because she's not shutting up over there, I hear. Come on. Oh, there it is. Did that just break it loose? In my frustration, I resorted to some violence. Come on, man. I really want to pull this motor apart. So you can see in there, the motor is not froze up. All right, what's froze up is between this guy right here, which is your crank arm, and the crank shaft, which is down there by that flywheel. You see that? And they're stuck together, and that's what I'm trying to separate. So if you see me struggling in all this, it's because this guy here, normally you would be able to rotate one without the other. There's probably a bearing at the bottom of the crank arm, and it's probably froze up because of shmoo. And unfortunately, that sucks right now. Wonder if I can just grab onto the wheel and spin it manually. Yep. Just a little bit at a time, not very much. And it does not like it too much. Come on. Oh, wow. Maybe it would be... Oh, yeah, there's definitely some shmoo down in there. Let's see. Get almost see it down there. See the white that's on the back wall? That is not normal. Okay. You know what they say? If you can't beat them, soak them in alcohol. For one thing, I'm soaking it 99% pure. Woo, man, I'll tell you what. Smells like I've been drinking. Because that is some strong stuff. That's 99% pure isopropyl. And that will definitely wake you up, man. It also get you a DUI. That's because just the smell of that would be so strong. All right. And I've kind of got it freed up now. So what I'm doing is I'm holding on to the flywheel really tightly and I'm pulling on the arm, the crank arm. And it's moving millimeters. So I can see my main sealed bearing, and you can see the alcohol going everywhere. I can see my main sealed bearing now. Come on. There it is. And there's the set screw. Just a couple of degrees and I got it. Yep, that's enough to get it. Yes! Victory! Okay. Let's see, metric or standard? Let's go with standard. It's an old pump. And let's see. Oh, that one's kind of small. Let's try 1/16. Business. Okay. And of course the set screw is also kind of seized. Darn it. Well, that's rough, man. So what I might have to do is soak this guy, soak it overnight. Here, watch, I'm going to bend a wrench. Or break it loose. Yes. Yes, sir. I thought for sure I was going to end up with one of those twisty wrenches. Let's go ahead and pull it all the way out. That way there, if I have to get some spray lubricant down there, I can do it. So, set screw. Yes. It's starting to give up the ghost now, folks. It is what it is. Come on. Come on. Yeah. I have a strong feeling that I'm going to have to soak this guy with some... oh, come on. Some lubricant overnight. Jeez. Anyway, at the very least, this pump is absolutely wasted. So there's a sealed bearing. Hold on. There we go. There's a sealed bearing right here. So you have a counterweight, which is basically the flywheel. There we go. And then you have a sealed bearing inside the crank arm. And that sealed bearing has the shaft of the motor going completely through it. So the shaft of the motor is connected to the eccentric weight or the flywheel. And what it's supposed to do is it's supposed to offset the force of the diaphragm. So as the crank arm goes up, the weight goes down. So they're doing this constantly and it weeble wobbles. But that sealed bearing got a bunch of schmoo inside it and is absolutely seized. Yes, I can get sealed bearings, and yes, I might be able to do something with that, but I can't torch it because it's in a polymer housing. So one of the things I could do is I could look up right here, T-squared pumps, and I can look this up. Right here is the part number, and this guy here probably comes as an entire unit. And it's probably fantastic if I can still get the part. This looks like an old pump, so the chance that I can still get the part is pretty rare. Pretty rare. All right. You guys can see behind the curtain. All right. Yeah, I just got alcohol like all over my desk, and it really is strong. It's really strong. Magic. Okay, guys. All right. I don't know what I'm going to do with this guy because I can't get that off. I can't get this guy off, this guy back here. This whole thing has just kind of got me stuck. And it's all because of bad design choices. I mean, it sounds like it's a cool idea until you have a bearing that gets froze up, so you can't rotate the shaft and you can't get this stupid brush housing off. Gosh darn it. If I can get one of these off, then I can separate it and we'd be good. Come on. Yeah, it's not happening. Where is it? Come on. I think that bearing might be actually giving up. Also, if I had some really thin needle nose. Come on, man. I don't want to break my hands. Okay, well, at the very least, I was able to move it enough to get my brushes out. So here you can see the spring-loaded brushes in a nice, neat little housing. So I have to be careful that those don't pop out, because if they do, they're gone. So I'll set that one off to the side. Oh, cool. So my pulling actually pulled the shaft right here. Look at that. There we go. So I was, yes. So I was able to get the shaft out. You can see that there was some on it. So what I can do is clean up the commutator bars. You see, how about right here? You see how there's a little gap right there between the brass. So what we can do is we can clean that with a little brass brush or a file. But these ones, you can see, they're not that bad. Look at that. So what sometimes happens is these commutator bars, they get shorted together, creates dead spots, and sometimes your motor won't spin because it's sitting on those dead spots. But this one here, those bars actually look beautiful. So I can clean that up. That one's still good. Permanent magnets are good. Here we go. All right, now I can show you guys actually what was going on. So right here you can see this is my counterweight / flywheel, and it's in a sealed bearing, and you can see right there, I'm trying to rotate it. Oh, wow, that is really gummed up too. Oh, look at that, I'm actually freeing it up a little bit. So I bet you if I were to heat this bad boy up a little bit, look at this. Here's a spacer, and it's rusted, completely rusted. So what happened is moisture got in here, down by the sealed bearing, and you can see what happened is it got in between this large offset weight, and it got in between there and the sealed bearing, and it didn't go anywhere because, you know, you had two large surfaces next to each other. And since it didn't go anywhere, what it allowed it to do is to rust. Let's see, what do I got that can handle that? I don't know if I have any left. So I do have contact cleaner, and I have some silicone. Cool thing about the silicone is it gets in and it dries up, and it also foams up. And when it foams up, it gets into a lot of areas. Oh wow. It's starting to free up. Check this out. There it goes. Okay. Well, I can actually replace the seal bearing. So seal bearings are really easy to get. It's just pressed into this polymer crank arm. Super easy. You can see as I use this silicone, what's happening is it's bubbling up a lot of the rust and a lot of the schmoo. That's one of the traits of using some of these silicones, that they do help agitate rust and crap like that. Let's see. I need a plastic dish. These are all things that I'll have to establish. Man, I'm still getting started, y'all. Okay. Oh, here we go. Here we go. Every garage has these. Okay. So I've got a little tray here. I am going to absolutely soak the thing with some silicone, and you can see the rust coming right out. You see that? Oh yeah, it's coming out really good. Yeah, what's up? Oh, excellent. Thank you. All right. So here we are. Look at that. Bearings feel a little noisy, but I could give them a hot supper, which means rotate it like really fast, let it break up that rust. But overall, replacement of that bearing is definitely going to be a must. That's actually rolling really easily now. Look at that. Okay. There it is. Wow. All right. Well, that was easy. Yeah. See, if I spray it right in that crack, rust comes out. Since this is just an emergency suction unit, actually, those bearings cleaned up quite well. I don't know if you can hear that. They sound like they're rolling really smoothly now. And I would like to get some grease in there, not just silicone, but get some actual like lithium grease or something in there. I don't know how I do that without like damaging it for real. But there it is, man. That's the anatomy of a failure. Compact suction unit. That would be user abuse. And that's because they clearly sucked some sort of liquids up inside the unit. And when they did, they stuck it away. And come to find out, when you do that and without cleaning it out correctly, it creates long-term damage. And that's what we have here. This one here is probably going to be salvageable though, because the bearings clean themselves up. Actually rolling really easily right now. So, yeah, see that? They cleaned up nicely. So, I'm going to let this guy soak and see what happens, you know? But look at all that. Yuck. Yuck. Because, like I said, that schmoo, we don't know what it was, but whatever it is, it's disgusting. That's for darn sure. Anyway, guys, so that's a complete teardown of a compact suction unit or emergency suction unit. And it's not that the equipment broke, it's that it was abused, and there we are. You know, staff, you know, that's half our job, right, is to fix the people. So there it is, guys. And I guess I'm going to have to end this stream because I have a absolute mess to clean up. So you guys got to see the inner workings of a brushed DC motor. You got to see the physics behind a suction unit, which is also a pump, an air pump. And yes, I can replace the bearing, Catherine. And you know, that bearing is probably only $2 or $3, $2 or $3, and it's just going to press right out. It's going to press right out. So my next thing would be to remove that counterweight. And when I remove the counterweight, the bearing's going to press right out after that. Super easy. So guys, thank you all for watching. I hope that this was at least a little entertaining because I was too curious about why this guy had failed, and maybe tomorrow I'll put it back together and see how well it runs. A few of these parts, like the diaphragm, they need to be washed out with soap, and that's probably what I'll do later on tonight, is soak a lot of these units in soap, not the bearing, of course, but he's going to get a bath in some silicone oil. I'm going to spray it down really good and probably hook it up to a drill and just let those bearings just run. So, you know, get it good and wore out and bleed out some of that rusty oil that's stuck in there. But that bearing is probably going to be absolutely fine when I run it a little bit. And some of the components just need to be washed a little bit, maybe with some sanding wipes, and I'll reassemble it tomorrow. So guys, thank you very much for watching, and overall, this has been a successful stream. I'm digging the camera setups, I really are. This made it way easier to use a wireless microphone and to just go forth and tear some stuff up. Now, in hindsight, I won't be tearing stuff up on my nice fake leather mat anymore. I have a silicone mat right here, and I don't know why. Why didn't I use it? This guy right here. A big one too. And next time, I'm gonna do better. That's all I can say. What a mess. All right, guys, have a happy Friday, and y'all have a good weekend, all right?